Hello friends, today I'll discuss about city star point for different type of protection which is used in a substation and also the city star point in case of metering purpose. So before going through this video, you can go through my channel and do subscribe my channel and also press bell button for notification of videos to be uploaded in future. So what does mean by the star formation of the city? For example, we have taken a figure where the red phase, yellow phase and blue phase city primary are connected as shown in this figure, where P1 of all the cities are connected towards the bus side of the substation A, and P2 is connected towards the line side if it is a feeder connection, or towards the transformer side if it is a transformer bay. And in the secondary side we have two terminal S1 and S2. Consider it that is only one ratio is exist. So normal general convention is one terminal is taken to the CRP panel for either for metering purpose or protection purpose as a red, yellow and blue phase via cables, and for return path the other end of the relay terminal, if it is a relay terminal, red coil, yellow coil and blue coil are sorted together and taken back to the another cable which is called the neutral. And in the switch here all the S2 terminal are connected and sorted together. That is the red phase of the S2 and yellow phase of the S2 and blue phase of the S2 are sorted together and connected with the neutral cable. So this is how the star formation is done. This formation of the star is different for different type of purpose which is used in case of substations. So first come to the example for metering purpose. Consider it is a feeder bay and current is flowing from the substation A towards the feeder. So in the primary side, direction of the current is from P1 to P2 direction. Due to this flow of the current in the secondary should be S2 to S1 direction, and here the connection should be with proper polarity. That is S1 of red, yellow and blue should be connected towards the meter red, yellow and blue coil with proper polarity. Otherwise there will be change of import and export power. That is, if it is a exporting power from the substations, and then there will be difference in case of instead of exporting it will show importing of the power. So it should be connected with proper polarity, and city star point formation should be in the towards the load side. That is, S2 of all the secondary side of the all the cities should be sorted together to from the neutral. So this is how the connection of city star point formation is done in case of metering purpose. Now come to the in case of non-directional relay. In case of non-directional relay, since the relay does not sense the direction of the current flow, that is, it only senses the magnitude of the current, and by means of the magnitude of the current it sends a trip signal if the magnitude of the current is beyond the setting limit. So here the city polarity and star point formation is not is a priority, but for general convention we should normally done that in the primary side P1 shall be connected towards the bus side and P2 shall be connected towards the feeder side, or if it is transformer P2 shall be connected towards the transformer side. And in the secondary side also S1 of red phase and yellow phase and blue phase are connected with proper polarity. Although the polarity does not depend on the functionality of the relay, but it should be ensured that city polarity of all the three phase cities should be in order. Now come to the case of protection of line protection. That is the case of distance protection, or it may be directional overcurrent protection for, or earthfall protection for line protection. Since it is a line protection, the direction should be towards the line. So P1 is connected in the bus side and P2 is connected towards the line side. So the general convention is city star point formation should be always done towards the protective object. Here the protective object is the line, and that is why S2 in the secondary side of all the cities are connected together to form the city star point. And S1 of the red phase, yellow and blue phase city secondary are connected toward the relay terminal as per correct polarity. Now come to the case of differential relay. So differential relay is provided in order to, in case of transformer, it is provided in order to detect the fault in the differential zone of the transformer. So what is the differential zone of the transformer? It is from the base city in the HV side, from the base city in the LV side. If any fault occur inside this zone, this relay should be detected. So it is provided in order to detect fault in the transformer. So in order to do that, P1 is connected in the HV side towards the bus side, and P2 is connected towards the transformer side in the HV side. That is, HV side is a 220 kV bus and LV side is a 132 kV bus. And again in the LV side, P1 is connected towards bus side and P2 is connected towards the bus, transformer side. It is a auto transformer. The rating of the auto transformer may be 160 MVA or 200 MVA. So in order to provide this, the city star point is towards the protective object. Here protected object is transformer. In order to do that, in the HV side, H2 terminal of all the city secondary are connected together in order to form the star point. Again in the LV side, H2 terminal of the all the city secondary are connected together in order to form the star point of the city secondary. So this is how the differential relay connection is done. Again in the relay, the connection should be with proper polarity. Now come to the directional overcurrent and earth fault relay. Normally in auto transformer beyond 220 by 132 kV or above voltage rating, directional overcurrent and earth fault relay is provided as a backup protection. So here directional should be towards the transformer side or towards the protective object. Here protective object is the transformer, so direction should be towards the transformer. In the primary side, P1 and P2 shall be connected with proper polarity. That is, P1 shall be connected always towards the bus side for both the voltage level, and P2 shall be connected towards the transformer side. And here the directional is towards the transformer, and the protective object is transformer, and CT sorting arrangement, that is the star formation, is done in the towards the protective object. And that is why S2 of red phase, yellow phase and blue phase is connected together to form the star point in case of the HV side, and also in the LV side to form the star point, and taken to the directional overcurrent and earth fault relay. Now comes to the case in case of busbar protection. In case of busbar protection, a feeder has been shown where CT is connected with proper polarity in the HV side. Now it is the protective object is the bus side. General convention is the CT star point in the secondary side of the cities are always done towards the protective object. Since the protective object is bus, the S1 of red phase, yellow phase and blue phase is connected together to from the star point of the city secondary, and S2 of red, yellow and blue phase are taken by a cable towards the busbar relay. It may be a feeder bay, or it may be a transformer bay, or it may be a bus coupler bay. The convention is general convention is same for all these bays.